Okay, so last time we looked at two useful formulas, that being distance and midpoint. I guess the next one we usually look at is the slope of a line, or the gradient of a line. I guess the first time you said it simply said, oh well, it's vertical rise over horizontal run. So that's the slope of a line. So there's my red line, which I'll call L. There's a 0.55 and a 0.21. Well, that's when we came up with a formula, because we said, well look, the vertical rise is the difference in the y values, and the horizontal run is the difference in the x values. So then we can substitute straight into that, and the slope of my line I've labelled L, 4/3. Of course, there is another way. Let's draw in capital L, so the blue line's capital L, and just say the piece of information I know is not so much a point that's on the line, but the angle that it makes with the x-axis. Well, it turns out the slope will be tan theta. Makes sense when you think about it, because if you draw in that right angle triangle we were using for distance, then rise over run would be opposite over adjacent, which is tan. Now the key is though, that angle has to be going to the positive side of the x-axis, because we know, well, the one I've got there, that blue one, would have a negative slope. The tan of an obtuse angle would give you a negative number. So if it's going down, then we go to the positive side, we get the obtuse angle. And similarly, the red line, it would have an acute angle, and that would be positive, and we want a positive slope for the red line. So okay, our one is tan of 120, so I know the slope of that is -√3. If I wanted to work out the angle there, I'll call it alpha. Well, now that I know the tan is 4/3, I can say, well, I know the tan of the angle is 4/3, so the angle that red line would make with the x-axis would be 53 degrees. So they're the different ways that we can find slope. Two lines are parallel if they have the same slope. And by the way, I have not spelt if incorrectly. That is the correct spelling in this context. If with two F's means if and only if. And what it means is your theorem reads both ways. So it's true to say that two lines are parallel if they have the same slope. That's true. So if you know they have the same slope, you can conclude, oh, these are parallel. But it reads the other way as well. If two lines have the same slope, then they are parallel. So if the fact that you know is that they have the same slope, you can conclude they're parallel. Not all theorems work both ways. So the IFF means it works both ways. So slope 1 will equal slope 2. Now, perpendicular, the negative inverse of each other. Another way of thinking of negative inverse each other, the two slopes multiply together to give -1. So A, B, C and D, we have these 4 points. We just don't know the x-coordinate of the fourth point there. So what would it be if the lines are indeed parallel? So the fact I know is that they're parallel, so I can conclude from that their slopes are going to be the same. Slope of AB, slope of CD, well, if they're parallel, then I know. So when you're setting out your solution, don't just go, oh, slope AB equals slope CD. Explain why it is. So I'm saying, well, okay, I'm using that condition. If they're parallel, I know. So if then statement. So we can now solve that, and we get A equals 4. A equals 4. Well, what about if they were perpendicular? Oh, well, if they're perpendicular, then I know they'll multiply together to give -1. And solving that little equation, we get A as -1. So it's an if-then statement. If I know this, then I can conclude that this is true. This time, we've been given 3 points. We want to find the fourth one if it makes a parallelogram. I think the easiest way of doing this is drawing a diagram. So let's plot the points we know. There are the 3. Now the question is, where do we place D? Remember, we always name quadrilaterals, or any polygon for that matter, in cyclic order. So this is A, B, C, D. So A, B, C, D must be, well, sort of underneath A, if you get what I mean. Where to put it? Well, AB is going to be a side, BC is going to be a side. So if I complete those, it's a parallelogram. There's where D will be. There's a quick way of doing this, and then there's a long way of doing this. Let me explain the long way. The long way to do this, people go, well, if I find the equation of the line AD and the equation of line CD, then I can find the point of intersection. Well, in order to do that, because I know the opposite sides in a parallelogram are parallel, so their slopes are equal. So I'll find the slope of AB, then I can find the equation of CD. Then I'll find the slope of BC, which will allow me to find the equation of AD. Then I'll solve them simultaneously and I'll come up with a point. A lot of work there. The quickest way is just using the fact that the opposite sides are parallel. So rise over run will be the same. Okay, so to go from B to A, I've run across 3 and I've dropped 5. So the exact same thing must happen when I go from C to D. Thus, the point is 0, -10. So that's the quick way of doing it, using our knowledge of what parallel means and just using the slope rather than finding all the equations. Now, if you want to prove 3 points are collinear. So collinear, co together, linear on the same line. You find the slope of AB. Well, it doesn't have to be AB. You can pick any of the 2 points you like. I've chosen AB. Then go pick another pair. So I've found AC. Now, if those 2 slopes are equal, then the 3 points must be collinear. Reasoning. Well, if they're equal, we know they're parallel. But they both contain the point A. Well, how can they be parallel and both contain the same point? Because parallel lines don't meet. Therefore, they've got to be the same line. So the 3 points are collinear. Okay, that's 7B.